We can combine the models that we've set up previously to create a model that is somewhat more realistic. In this case, we'll have recharge applied to our region. The streams will be held at a head of 0. Initially, the recharge will produce a ridge of high hydraulic head between the streams. Then we'll use that condition as the initial condition for the transient model, where the hydraulic head is raised from 0 to 10, and that produces the pressure wave that moves from the bottom to the top. And in this case, the pressure wave will interact with this ridge of high pressure that's created from recharge. So here's the model that's set up to represent those conditions. If we expand it and look at the geometry, we can see that it's this 1,000 by 1,000 rectangle that we've used before. And we expand out the physics, and we'll check out the boundary conditions. This top boundary is held at a head of 0. The bottom boundary is a head of 10. The storage model, this describes the parameters that we need for the transient model. And the mass source, this describes the recharge, just like the steady state model that we set up earlier. The mesh is the default mesh that we used previously, and a thing that is new here is that we've added an additional study. This simulation requires 2 studies. One where we run the model at steady state. This creates this ridge of high hydraulic head, and then we save that and use that as the initial conditions for the transient model. In this case, we have a steady study and a transient study. So the results are shown here. These two are the results for the steady state model, and we can see this is the pressure, and we have a ridge here down the center as expected, and our profile is this parabola that looks like so, with a high hydraulic head here in the center. The transient response looks like this at 1 e to the 7th. We can select some different times, a little bit earlier, and there we see this ridge from our steady state conditions, and as we move later in time, you can see that we have this pressure wave that starts here and moves from bottom to top, ultimately giving a pressure distribution that looks like this. It's a little more insightful if we look at this in as a graph along a cross section. This is the same cross section that we used before, and you can see that this is the steady state profile, and that's what the heads look like before the head in the stream is changed. But then at time equals 0, the head moves from here at 0 to 10, and we have profiles that look like this. This is increasing time, and it reaches a new steady state shown by this blue line. We also have the player set up, and we can take a look at what this looks like. We play it as a function of time.